Welcome to the Neural Implant Podcast, where we talk with the people behind the current events and breakthroughs in brain implants in an understandable way, helping bring together various fields involved in neuroprosthetics. Here is your host, Laden Yurachek.
Hello, everyone, and welcome to the Neural Implant Podcast. Today's guest is Dr. David Friedenberg of Battelle, and he works for a company, very interesting company called Battelle, and this has something like 20,000 employees, and it's based in Ohio, and they're kind of like a contractor. They're a not-for-profit contractor, which helps out with a lot of research. And what they were doing, I reached out to them, and what they were able to do was demonstrate graded control of muscle contraction in a paralyzed limb. So we have talked to many guests, including Chad Boughton, and one of the very first ones, of the paralyzed patient that had the BlackRock microarray implanted in his brain. And with this, he was able to do different things. So play video games or drink a cup or all these kinds of things. And what they were able to do is basically have graded flexion. So it wasn't like on-off kind of thing. It was much more gradual. And so instead of like, if he wanted to pick up an egg, he wouldn't either drop the egg or crush the egg. He would be able to actually firmly grip it. And so yeah, they were able to do this using both software and hardware. And we'll talk more on the other side.
So several years ago, we were looking for sort of our next big project to tackle. And we identified neurotechnology as one of the areas that we wanted to get into. And we were trying to figure out, where within neurotechnology should we go. And as you mentioned, Chad was a research leader here. He had identified from some of his previous work that this, recording from the brain, stimulating the hand, those technologies were all sort of out there. He wanted to try to combine them all together into one system so that when a paralyzed person thought of moving their hand, the system would record brain activity there and then decode that activity to figure out what hand movement the user intended, and then subsequently stimulate the arm to actually have the hand move in the right way.
Yeah, sorry. You're saying that Battelle chose to do this, that Battelle chose to get into this, and I don't know why, but I was under the impression that they were contracted into it. I guess they were like pulled into it or something like this, but you're saying it was the other way around. They pushed themselves into it, right?
Yeah, this was an internally funded project with our collaborators at Ohio State. So Battelle, sort of very roughly, Battelle did most of the technology work, and Ohio State did the surgery and patient recruitment and care. Throughout the whole project, we've been partners, and we sort of collaborate on all our research and all that.
Yeah, so how does this work? I've actually never had a contractor on the show or like a contracting company. Yeah, so you're saying that you guys were responsible for the technology. I'm a little bit shocked, actually, honestly. Like I was in this like la la land where I thought the universities did everything, but here's like the real powerhouse behind it. Is that kind of accurate? Or I mean, I'm a little bit surprised that this is maybe how it really works.
Yeah, well, we're kind of unique. So we're a nonprofit organization. We do a lot of contracting, and I say nonprofit. We do make profits on our contracts, but those profits, as opposed to going to shareholders, mostly get reinvested into either the community or into the company. And so the ones that get reinvested into the company, some of that goes into what we call science and technology projects. So that's projects like what we call NeuroLife, where we develop new technologies that we think. For this one, certainly it benefits the community. The idea is that we'll be benefiting spinal cord patients down the line. And then it also is developing capabilities for us that are of interest to our clients.
Okay, so do you think you guys figured out, or did you accomplish your goals with this, or is this like a continuing project, and have you only just begun?
Well, it's a little both. So we're certainly really excited, the first couple times that we saw Ian move, and that was, a really emotional and big moment for us, that, all this effort that we had put into making the system work actually worked, and Ian was able to control it. As you mentioned, as he got better using the system, he was able to do more and more things. He's able to play the Guitar Hero video game. He's able to do a lot of functional movements, gotten to the point where now he'll suggest to us movements that he would like to do. So for instance, one of the ones that he really wishes he could do is swipe his credit card. And so we worked with him, and we figured out a grip, and he's able to, pull the credit card out of his wallet, swipe it, and put it back into his wallet, which is, one of those movements that wasn't something that really occurred to us, but it's something that would really improve his life, because he wants to be able to go and live his life and go to the store or go to the restaurant and sort of interact as normally as he can. And then follow up, it's ongoing. So we're still working with Ian. We're actively working to get a second patient involved into our study, and so we're certainly continuing in that front.
Yeah, I hadn't heard about this credit card swiping thing. I guess maybe next on the list is like eating a burrito or something like this. Yeah, so this is really interesting. This is like a whole new way of doing things. So what was your guys' role? I mean, it sounded like the solutions that you had, so basically the gradation, so it wasn't like on, off, like kind of jerky movements. Your guys' contribution seemed like it was, okay, like he can have more like refined movements, like a ballerina or something like this. How did you guys do this? Was this a software fix or a hardware fix, or what was it exactly?
So it was a combination. When we first started working with Ian, we were doing these kind of on-off movements where he would initiate a movement and it would just be sort of full force on. But we very quickly realized that for any sort of functional movements that you do, so think of gripping objects. So like if you want to pick up an egg, right? If you grip it as hard as you can, you're going to break the egg. If you grip it too lightly, you're not going to hold it and you're going to drop it. And so there's a lot of these movements where you really need to be able to grade your force exactly in order to interact with objects. And so that was sort of the motivation behind it. And the most recent paper we published, we were looking at not so much the grip strength, but we were looking at if he could grade his wrist force. So he had a pointer on his hand, and he was asked to point at different targets by sort of flexing his wrist to different angles. And so it was a combination of the software being able to move from sort of an on-off to a shades of gray in terms of decoding. And then it was also a matter of how do we actually physically move the wrist in those ways using our stimulator.
So what are some of your biggest challenges in this work?
Well, there's a lot of big challenges. So part of it is on the stimulation side, just getting the movements correct, making them look natural, making them feel natural so that Ian can control it. The software side of it is where I tend to spend most of my time on the decoding front. So there are definitely a lot of challenges there. I think going forward, though, the big challenges are in how do we take these kinds of technologies outside of the lab. So we've been doing a lot of demonstrations and writing a lot of papers, but we're looking forward to how do we get this out of the lab? How do we make an impact on patients' real lives? And so I think that's where a lot of the biggest challenges lie.
Yeah, so those are going to be the future breakthroughs, as well as making it a little bit more portable, because it's probably very confined to the lab. Like, can he use it? Does he have to go to the lab in order to use it, or how does that situation look like?
Yeah, right now he has to come into the lab. It's a full table worth of equipment. There's a big cable that he has to plug in to connect his brain to the system. The stimulation sleeve and all those associated electronics are pretty bulky. We're in the process of trying to miniaturize a lot of those components. And then the other piece of it is actually building a system that's usable for a patient. So right now when he comes in, he spends the first part of his session training, so building up the algorithms. And then he spends the latter half of the session actually using the algorithms. And you can imagine if he took the system home, that wouldn't be the way he wanted it to work. He'd want to just wake up and be able to go with it. And so that's something we're doing now that we've been doing this for a couple of years. We have a good amount of data trying to build up algorithms that are sort of robust to all the day-to-day variabilities that you might see.
Wow, so even after a few years, you still have to reset it and train the algorithm. So I saw something like 3 years, it's already been in, and it's been working and everything like this. How many sessions would you say?
We try to do 2 sessions a week. For the first couple of years, it was 3 sessions a week, and we've gone down to 2 sessions a week as Ian's going back to college, so he's going to finish up his degree in accounting, and so we've had to scale down a little bit. But it's roughly been 2 to 3 sessions a week for the past 3 years, with a couple breaks here and there.
Wow, so like 300 to 500, something along these lines of number of sessions. That's incredible.
It's a lot of data.
Yeah, I think so. Wow. Okay. Yeah, that's really interesting. And yeah, I'm still kind of surprised that you're not able to use the old data or something like this, because the same neurons are there, right? And they should be activating under the same conditions. Why is it that you have to, I don't know, retrain it every single time?
Sure. Well, the same neurons are there, but over the course of years they change. So some of them will die off, some of them will regenerate. But you have to remember, Ian's state is always changing. So, if he has a cup of coffee right before he comes into the session, the brain data looks a little bit different. All those sort of things that affect your brain and my brain also affect Ian's brain. So if he's not feeling well, if he doesn't get a good night's sleep, if he's on any sort of medication or caffeine or any of those things can affect it. But we're also making a lot of progress. So I don't want to say that we have to retrain every single day. We've made a lot of progress on our algorithms so that we don't have to retrain quite as frequently. And we're actually hoping to publish some work here very shortly where we show some really long-term performance without having to retrain at all.
Wow, that's kind of crazy. Yeah, so you're saying like even a cup of coffee or doing anything like this could drastically change everything. So what does this say for the future of potentially neuroprosthetics?
Well, I think it says that you have to be cognizant that there is a lot of variability in the data, and you have to be ready to handle that. So part of that is just having this large data set that we have that we're able to train and learn about this variability. And then part of it is also, our patients learning how to use the system. So it's just like riding a bike or learning how to drive. There's a process of learning how to use the system. And I think Ian will tell you that, as he's learned to use the system, it's gotten easier and easier for him.
So yeah, if you had a magic wand, what would you change?
Well, there's lots of things we'd like to change. Certainly, we referenced a couple of them. We'd love to get all the equipment down in size so that we could mount it, make it all mobile, make it all portable, get rid of all the wires. I think that would be the biggest thing because, we would love to get it to the point where Ian and people like Ian can use the system, can take it home, and it can really make a difference in their lives because right now it is constrained to the lab. So that would be certainly the thing that we're all shooting for.
Yeah, so if you describe it, I mean, you basically have the brain implant and like a wire sticking directly out of his brain, and then these electronics could be potentially miniaturized to be like, I don't know, a backpack or something like this, and then that would connect to basically like an arm cuff, something like this, like an electrode cuff, which would like stimulate his muscles electrically, something like this. Is that kind of the ideal that you would be shooting for?
Yeah, exactly. So we would like to get rid of the wire from the head, have that entire system be wireless, have it communicate with a device that he could mount on his chair, and then have the stimulation system also be self-contained and mounted on the chair, something that maybe you would just have to recharge once a day like your phone. And then we envision the stimulation sleeve to be just that, an actual clothing sleeve he would wear on his arm that if you walked by him, you might not even notice that he was wearing something. You would just think it's a piece of his clothing.
So what is it now? Is it something different, a different kind of sleeve?
Yeah, so right now the sleeve that we're using, if you see a picture of it, it looks like little strips of electrodes, so it certainly doesn't look like a piece of clothing or anything like that. We have a prototype that we're going through the approval processes right now that looks much more like an actual sleeve, like a cloth material, and the electrodes are built into that. But if you're just looking at it from the outside, you can't see the electrodes because they're touching the skin. So on the outside, it really just looks like a fabric sleeve.
Yeah, I mean, I don't know. Like, to me, it sounds pretty achievable. I mean, especially that you don't have to miniaturize everything so small. I mean, like to the size of a backpack or something like this, or a purse, but more whatever can go into the undercarriage of a electric wheelchair. So, the weight constraint potentially could be, it could even be like 100 kilos or something like this. There really is no weight constraint as long as the chair could handle it. So, what kind of time frame would you say that this might be possible in?
Well, I think it's still a ways away. Still working on building all the miniaturization parts, and some of the parts are our collaborators. So the chip in his brain is a Blackrock Utah array, and we use that because it's the only chip that's approved by the FDA for use in humans. So part of it'll be getting some of these devices approved by the FDA, which can be a challenging process for very good reason. And then part of it is developing all these pieces of technology so they work together. As you mentioned, you have to worry about the weight, you have to worry about the battery life. There's a lot of considerations that go into it.
So many years, especially probably mostly because of the FDA process, or what?
It's a combination. I mean, you have to build up the technology before you can submit it to the FDA. So we're working on certain pieces of the technology, and I think by the time it all gets put together, it'll be several years out still.
And how many people are working on it from Battelle's side?
Our team, we have about, I would say, 8 people or so who work on it the majority of their time, and then we have a much larger team of people who sort of contribute smaller amounts, who might come in for a couple weeks to solve a specific problem and then go back to doing their normal work. But it's a core team of about 8 people. Yeah,
like the towel boy and the cheerleaders, right?
Yeah, except they're all electrical engineers and mechanical engineers and human factors and statisticians.
Okay, so a little bit more qualified than towel boy. So I'm curious, as I said, I've never talked to a contracting company. How did you get into this company? I mean, how would you maybe recommend that people would go into it, or would you recommend it?
Sure. So I got into it. I'm a statistician by training. I really got into statistics because I love science and I love all different aspects of science. And being a statistician seemed like a great way to sort of dabble in a lot of different areas of science. And that's something that my company Battelle does. And so when I finished up grad school, I talked to them and it made sense. And I came here, and that was almost 8 years ago. In my first couple of years, I wasn't working on anything neuroscience related. I was working on all sorts of different problems in all sorts of different areas. And then when Chad brought this project in and he brought me in, it became really clear to me that this was the most exciting project I'd ever seen, both at Battelle and outside of Battelle, and something I really wanted to commit to. And so since then, I've been spending most of my time working on this project.
And so you've been working with Ian for the patient for 3 years, and so and you were there for 8 years. Well, I'm doing the math. So did you start working on it 2 years before you started working with the patient?
Yeah, so we were working on it for quite a while before. It's really before we turned the system on and Ian was able to use it. So Ian went through several months, probably 6 months or so, where we were just using the stimulator, and that was trying to recondition his muscles, trying to figure out a mapping, between the different electrodes. When we turn this electrode on, what's his response? Trying to figure out how to evoke different grips and different hand movements with him. And then the whole surgery process and the recovery process took a while. And then, we wanted to be ready to go when Ian was ready to go. So there was a couple of years there where we were just sort of building up the system. The stimulation box, the sleeve, the algorithms, those are all things that we developed. That took a lot of time to get all those pieces together and ready to go.
Interesting. And so many listeners are just starting out in this field. What are some recommendations in case they want to work for a contracting company?
Well, working for a company like Battelle, we solve really challenging technical problems. So we hire lots of PhDs and lots of master's students and engineers. We also have lots of interns. So, a lot of our employees come to the intern program. We have several interns on our NeuroLife project now who help out with running the sessions and writing code and helping us, do data analysis, all those sorts of things. But really, if you have a strong technical background and academia doesn't seem like the route for you, I think a place like Battelle is kind of in between an academic institution and what you'd consider like an industry, like working for a medical device company or something like that. So we kind of get to dabble a little bit in both fields.
And are there other contracting companies? Actually, I had done an internship at a company called Fraunhofer Institute in Germany. Is this something similar?
I'm not familiar with that particular institute. We're kind of similar to, there's a lot of national labs in the U.S. that also do similar kinds of work, and we're involved with a couple of those national labs. That's probably the closest comparison. And then there's other contracting firms that are in certain areas that we compete in, but we have a pretty broad portfolio of projects. So we go from neurotechnology to environment to defense, and sort of everything in between.
Yeah, I was doing a bit of research about Battelle, and it says something like 60,000 employees or something like this. So yeah, and a lot of, like you said, a wide range of projects.
Yeah, I'm not sure about if it's fully 60,000, but we're a fairly large company, and then we also help out with some of the national labs.
Okay, well, if people want to find out more about your research or Battelle's research, how do they do that? How do they either contact you or find out more?
Sure. So you can visit our website. It's www.battelle.org. That's BATTELLE.org. And if you go on there and search for NeuroLife, all one word, you'll find the links to all our papers and all our current research and some cool videos.
Excellent. Thanks so much. This has been really informative.
All right. Thank you.
Hey guys, hopefully you enjoyed that. Yeah, as you might see from the length of this interview, I was a bit nervous, because actually we weren't alone on the call. There was another lady, nice lady, Katie Delaney, who was listening in on the conversation. So to make sure that Dr. David Friedenberg didn't reveal any company secrets. So I don't know. I was a bit nervous about like what to dig into or what to ask about. So I was very much like, okay, that's the answer, and I won't dig any further. I don't want him to get kicked from under the table. But yeah, I found it very interesting. These gradations of the signal, basically software fix with this. But I'm also a little bit surprised. I mean, I had heard about this case and this patient and everything like this, but I had no idea that they had so many sessions, actually. I was a little bit, I was quite surprised with this. Like 300 sessions or something like this. I was also very interested, as you may have heard, about the actual organization, Battelle. And we were talking a little bit outside of the recording that it's very similar to something called Fraunhofer Institute in Germany. So it's like not necessarily a business, not a for-profit business, not they are not for profit, but it's kind of in between. They're contractors and they just kind of help out institutions. And I think this is really cool. I think this is kind of like a happy medium, so here's my bias, and I think I'm going to offend just about everybody here, is I think university is a little bit slow moving, and I think it's kind of like a lumbering giant, and it's kind of dependent on grants and publications, and it kind of skews the results or skews the success markers of academics and everything like this, which I don't know, I don't think it's necessarily good. And then on the other extreme, business is kind of like profit only motivated, and if it doesn't make a profit, then they're not going to create it, even if it is like a helpful thing. So outside of the interview, they were talking about less profitable kinds of medications that maybe the pharmaceutical companies don't really want to touch, and they do it because they're not really driven by it. So I think this is really interesting. I wish more of these kinds of companies existed. I think it's very, very interesting. I think it could really do good to bring both the benefits of business and academia and combine them into something that's even good. Of course, there probably are some disadvantages or something like this. Anyways, hopefully you guys enjoyed this, and we'll talk more another time.
Hope you enjoyed the show and were able to learn something new, bringing together different fields in novel ways. Until next time on the Neural Implant Podcast.